Hey everyone. So I wanted to go over a few practice problems for algebra. First, and if you are here for pre-algebra, I will probably start that within the next 30 to 45 minutes. I spent a lot of time yesterday talking about polynomials for algebra, so I felt like we could go over a few practice problems that are on that guided practice if anybody has any, or I could go through a few IXLs that I have set up for adding and subtracting polynomials. So what I'm going to do is I'm going to go through a few problems when we just have a few binomials and then a few trinomials, and then go to where we have 3 polynomials that we're either going to add or subtract. And then if you have any questions, please let me know. Go over those as well. Go ahead and start with, if you are on your guided practice, we're going to start with number 3 and then 5. So as we discussed yesterday, for adding and subtracting binomials, the big thing you want to do is that you want to group your like terms together. So we have 2n to the third and 5n to the third. So these would be like terms. So I'm going to underline those. That's a terrible 2. I was going to go with the 5 first. So I'm going to erase it all. And if you don't need to write this step, that's fine, because some of us can just go ahead and add that in our head, because we know they're like terms. And then we're going to have 4 and 2. Those are alike as well. Those are both constants. So 2n to the third plus 5n to the third is going to be 7n to the third plus 4 plus 2, which is going to be 6. And then if I was to name this or label this, we would go off the degree first, which the degree for this polynomial is 3. That's our highest exponent value. So it's going to be a cubic. And then based off the number of terms, we have 2 terms. So remember, with 2 terms, bi means 2, so binomial. So that's how we get for number 3. So now we're going to go to number 4. This time we're subtracting. You can do the stack method if you prefer. Just make sure the terms are alike above each other and below each other. And then I'm just going to do add the opposite instead. So when you're subtracting, you want to add the opposite. So I'm going to change my signs for my second set. So this is going to become a plus. It's going to become a minus. This is going to become a minus. So with doing that, we're then going to have 3a squared minus 2a squared. So 3 minus 2 is going to be just 1, and a variable that has a coefficient of 1 is just itself, so a squared. Then 1 minus 4, or 1 plus negative 4, which is going to be negative 3. And that would be our final answer. And if we were to label this, this would be a quadratic binomial. Hopefully that helped for those two. So now I'm going to move on to number 13. And then I'm going to go in, then I'll come back and do number 11. So number 13 is just an addition problem, and then again we're going to highlight or underline our like terms. I'm going to look for the highest degree because I want it to be in standard form anyway. So 4, 5, 3, 3, 5, 4. So our exponent of 5 is going to be our highest degree. We're going to combine this together. So we have 13x to the 5th plus 5x to the 5th. So 13 plus 5 is going to be 18 x to the 5th. We then have negative 4 x to the 4th and 7 x to the 4th. So negative 1 plus 7 is going to be positive 6 x to the 4th. And then our last term is going to be 6x to the 3rd plus 6x to the 3rd, which is going to give us 12x to the 3rd. And if I was to label that, going off of our highest degree, that's our exponent is 5, so that's going to be a 5th degree. And the number of terms is 3, so it's a 5th degree trinomial. And again, you don't have to label it, I'm just offering that up as extra practice as we're going through with the guided practice. And then I'm going to work on number 11. So with negative 11, I'm sorry, number 11, not negative 11. Looking at our highest degree, so it looks like a to the 5th is our highest degree, a to the 5th. So 12a to the 5th minus, oh, and this is a subtraction, so we need to change all the signs real quick before we do that. So to add opposite, and the opposite. So 12a to the 5th plus 2a to the 5th is going to be 14a to the 5th, negative 10a to the 3rd, but we don't have one here, but we have a positive 14a to the 4th, so that's going to come first, so plus 14a to the 4th. So we're done with those. Then we're going to have our negative 10a to the 3rd. And then we have negative 6a minus 10a. So that's going to be negative 16a. So if I was to label this, going off of the highest degree, it would be a 5. So it's a 5th degree. That's a 5, I'm sorry. Four-term polynomial. All right. So I'm going to move over and I'm going to do 2 from the end, and then I figured I'd do a few practice problems from IXL. I'm going to do 26 and then I'm going to do 27. So 26, we're going to have negative 9v squared. And let's go ahead and write the degrees on the top so we can kind of put this in order. So we got 2, 1. This is going to be 2, remember 1. 1 is going to add those together. So you get 2, 2, 2, 2, 2. So this will be our last term. So I'm going to do our v squared first. So we have negative 9v squared, positive v squared, negative v squared. So negative 9 plus 1 minus 1. So these would just cancel out. So you're left with negative 9 v squared. So we're done with these three right here. So let's move on. I'm going to do the uv ones. That's going to be negative 2uv, 4uv. So negative 2 plus 4 is going to be positive 2uv. Then we just have 1 negative 2u squared, and then negative 8u. So that would be our answer. Does it matter if you do v or u first? As long, so you can do u squared first rather than v squared first, that's fine. The only thing is that negative 8u needs to be at the end. And if we were to label this, this would be a quadratic. And 1, 2, 3, 4, so that's a 4-term polynomial. Again, you don't have to label it, I just was saying that. And also, let me see how they, because I have not checked their answers on this, so I know that 6, they probably did. Oh no, they did the v's first like I did. Okay. But yeah, no, the u and the v, since the degrees are the same, you could have had negative 2u plus 2uv minus 9v squared. That's fine. Alright, so 27, we're dealing with subtraction, so let's go ahead and change those signs so we can add the opposite. So this becomes a plus, adding the opposite, adding the opposite, adding the opposite, adding the opposite, adding the opposite. That's just going to be a negative. All right. So looking at each one, we have a degree of 2. This would be a degree of 5 because 3 plus 2. This is the same monomial, so 3 plus 2 is going to be 5. 2, 5, 1, 1, 2. So we're going to start with our one that has a degree of 5. So x cubed y squared, x cubed y squared, and that looks like all of them. So 7 plus 7 is going to give us 14. So these are done. Then we're going to go with our x squared. It's our next highest degree of 2. So underline all those real quick. So we have 4 plus 6, which is going to give us 10, minus 9, which gives us 1. And if we're just having one of the variables, that means then it's just a positive, and it was a positive one, so just x squared. And then we're left with then our positive 4x and negative 10x. 4 minus 10 is going to give us negative 6x. And that would be our final answer. And if you were to label this just really quickly, that we'd say 5th degree trinomial. 5th degree trinomial, because you're naming it off of the degree first, which is a 5. Or remember, 4 or more, you just say 4th degree, 5th degree, 6th degree. And then you name it off the number of terms, which in this case there's 3. So 3, think of like a tricycle. The TRI, the prefix TRI stands for 3. So it's a trinomial. All right, so I was gonna I'm gonna move this over, so we're gonna get some just clear space. I guess we're going to go this way. Space this way. Cool. Alright, so I need to bring this problem up so y'all can see this. Okay. So this is just from the IXL. If you wanted to do a few practice problems for there as well, instead of doing the guided practice, there's this as guided practice as well, or if you just want some extra help with it, that's an option as well. So this is going to give us a binomial. So we have two terms here, followed by three terms here, so a trinomial. So we're adding a binomial and a trinomial. So let's add those together. I'm going to write them on the whiteboard. So we have, I'm going to see where we're good. Okay. Oh, well, let's change that. So 4n plus 6. And we're going to add that to 5n squared plus 6n plus 7. So looking for our highest degree. Our highest degree in here is it going to be a degree of 1? Then we're going to have a degree of 0. Remember, constants have a degree of 0. This is going to be a degree of 2, a degree of 1, and a degree of 0. So let's write this in standard form. So we only have 1 degree of 2, so we don't need to add that to anything. So that's going to be 5n squared. So that's taken care of. So then we have our degrees of 1. They're both they both have a variable n. So 4n plus 6n. 4 plus 6 is going to give us 10n. And then we're going to add our constants, our positive 6 and our positive 7. So if we add those together, we're going to get 13. And that would be your final answer if you're going to plug that into IXL. So to do that, we're going to do 5. I would press this button next. Oh, whoops, no you wouldn't. That's my mistake. You're going to press n first, then press the exponent. So we'll give it an exponent of 2. You can then press the right arrow to come back down and write plus 10n plus 13. And if we check that, well done, so we did well, so we can go to the next one, and awesome, now we got a subtraction. So what I'm going to do is I'm going to write that underneath. I'm going to give us a nice little mark so we know that this is a different problem. Let's lock this in. And I'm going to work on the next one. So this is going to be 7j squared plus 2j plus 5, and put that in parentheses. Sorry, that's a little messy over there. Minus 3j. I'm going to give me some room because I'm going to have to change these signs. Alright, so we're subtracting, so we want to add the opposite instead. So I'm going to change this to a plus. So add the opposite. Add, now here I've been making this a subtraction sign. You don't have to do it that way too. You can instead just add a little negative here, which I think I'm just going to do that just to help out. So add the opposite. And then we're going to combine our like terms. So we have a degree of 2, 1, 0, 2, 0. So we want to combine our j squareds first. They're our highest degree. So 7j squared minus 3j squared is going to be 4j squared, because 7 minus 3 gives us 4. So we now know that we have 4 of these j squareds. Then we're going to combine. We only have one that has a degree of 1. So that's going to be then just plus 2j. And then we're going to add our constants, so the ones that have a degree of 0. So positive 5 minus 4 is going to give us positive 1. So this would be your final answer. And if we were to label that, that would be a quadratic trinomial. Let's get over here. So let's go ahead and plug this in. So 4j exponent symbol squared. Oh, that's weird. Why is that not? Oh, there it goes. Okay. 4j squared plus 2j plus 1 should be good. Let's press submit. We did well. We got 2 right so far. Alright, let me do 2 more. Actually, what I'm going to do is I'm going to jump up a level so we can do a little bit more challenging one, so I'm not boring y'all too much with this. So now I've jumped up a little bit of a level up here, so we're now dealing with 2 trinomials. I'm going to write that real quick, and then I'll probably jump up one more level, and then I'm going to switch over to pre-algebra to go over some volume and surface area. And I will be streaming again tomorrow, probably around the same time. And again, I will make a post on it, and then I'll have a definitive schedule next week once I hash out all the details. Alright, so 9w squared. Actually, just to make this a bit easier for my writing, I'm going to scroll this up some. W squared plus w plus 5 parentheses add 9w squared plus 2w plus 2. Alright, so we have a degree of 2, a degree of 1 because we had an exponent value of 1. We have a degree of 0. Remember, our constants are degrees of 0. And in case you didn't see the video yesterday, just as a heads up, the reason it's a degree of 0, so if I was to write 5, there would be an exponent there, except, I'm sorry, a variable there, except that variable is going to be raised to the power of 0, because anything to the 0 power is going to be 1. So this is like saying 5 times 1, so that simplifies just to 5. So that's how we get that degree value of 0 as well. I'm going to erase that so you don't get confused as that being part of the problem. Hopefully. That was weird. Okay. So we have degree of 2, degree of 2. So 9w squared plus 9w squared is going to be 18w squared. And we have positive w and a positive 2w. So this would be 3w. And then the last one, positive 5, positive 2. So you add that together and you get 7. So if I was to put that into our little IXL problem, 18, right arrow, plus 3w, plus 7, and boom, we got that right. I'm actually going to do this one before I jump up a level. So this one is going to come out to a kind of funny answer. So 8p, oops, plus 1 8p plus 1. So in essence, if you see this right off the bat, you're seeing that we're subtracting the same thing, so that it should just cancel it out. But let's go ahead and go through this. We're going to add the opposite, add, and I'm just going to get a little negative sign, so add the opposite. So 8p minus 8p gives us 0. And then positive 1 minus or add negative 1 is going to be 0. So 0 plus 0 is just 0. Be our final answer. Submit. And we got that one right. So I'm going to jump up a level. And I'm just going to scooch this down just so we can get some more space. So 7z cubed plus z squared plus 6z. I got z cubed plus z plus 1, and this is an addition problem, so we don't need to change the signs. So 7z cubed plus z cubed, 8z cubed. We have a z squared, but we don't have a z squared over here, so it's just going to be plus z squared. Then we got 6z plus z. So then that's going to be plus 7z. And then our last one this would be just plus 1. Plus 1, so this would be our final answer. So let's plug that in, 8z cubed plus, oops, z squared plus 7z plus 1. Boom. Got that right. Alright, so let's do one more. And then I can take any other questions real quick before I go into pre-algebra. Let's work out this last problem real quick. We have 8g cubed plus 8g plus 2 minus 3g plus 2. Alright, so we're subtracting, so we're going to add the opposite. So we only have one g cubed, so I'm just going to go ahead and write that. So 8g cubed. We don't have any g squared, so we're good. So let's move to our 8g and negative 3g. So if we add those together, 8g minus 3g is going to be positive 5g. And the last one, positive 2, negative 2. So those end up to be canceling out. So that would be plus 0. But anything plus 0 is just itself, so you don't even need to worry about writing that. So let's fill this in. 8g cubed plus 5g. And you could put plus 0 in here, but I wouldn't. It's just extra stuff you have to type, and I wouldn't do that for Power School or for anything like that, because you need to know that anything plus 0 is just itself, so it just doesn't need to be there. And we went up, so we did good. We got that one right. Do we have any other questions on stuff about this, or are we good? Okay, well, if you do have questions, feel free to email me. If you're watching this later, you can email me. I can work out some problems that way. And just take your time with this and do the guided practice to kind of help you. But remember, the only thing you really have to turn in is the independent, and the mastery stuff is the stuff that I'm going to look over the most. But I am here to help, so feel free to contact me if you need if you have any questions or anything. I'm going to switch over to pre-algebra to kind of go over some surface area. We did volume yesterday, so I'm going to go over some surface area problems today. But yeah, I miss y'all for algebra who are leaving, and I'll talk to y'all tomorrow or hear from you later. Just give me 1 second to just switch over. Alright, y'all, so I'm going to go over some pre-algebra concepts today, and I just wanted to bring up at least the formula sheet because I was having some questions about some of the materials, so I felt like if I went through some practice problems to help y'all out, I felt that'd be good to go through. The only thing I am going to say is, like with the IXL, we did volume of cones. The reason I didn't assign any for like the ones that just say prisms is because even though they have the rectangular prisms, which I think is good review, They also include triangular prisms, which is no longer asked for this math year. You will go more over that in geometry. So I'm not going to do too many problems from that IXL just because it can get kind of confusing with what's the base, what's the height. It can be a vague concept. So we're just going to practice with just straight surface area for cones. However, I will tell you that the concept is pretty much the same. When we go over it, we're just going to be using this formula. The only difference is that you would be dealing with perimeter. And we can kind of go over that at the same time when we go over these. So I'm going to write both these down, and I can kind of show you how they are, in fact, the same thing. So with a pyramid, you have the surface area of the, and this, we're just going over surface area today. I did volume yesterday. So this would be 1/2. This L for surface area, if you look back over at our formula sheet, there's, and I know it's a little difficult to see, but if you looked at the form that was on the lesson plan, at the very top they gave you the formula sheet. This L is what's called the slant length. So it's the length that goes along the side here. It makes a perpendicular, I'm sorry, it's perpendicular to the base length. Not the area of the base, not that big B, but the base length. So in essence, it's the height of this triangle if we're looking at it just straight on. So that's the slant length, and then it's going to be times the perimeter. That's what the little p stands for, and that's the perimeter of the base. So again, if we were looking at this, the perimeter of the pyramid, starting from this corner here, we would add here this length in the back, and then this length along the sides. So you want the perimeter of the base, and depending on what shape it is, you would just use the perimeters formulas that are right here. So if it was a square-based pyramid, it should be 4 times s, or 4 times the side length. If it is a rectangle, you could do 2 times the length plus 2 times the width, and that would still give you the perimeter of this base. And then the big B is just the area of the base. Now we're going to add that to the area of our base, and then we're going to be good to go. For a cone, the surface area is pi r squared plus pi r L, and again that is the side length, the slant length along the cone, that edge. Now, so I am going to use this highlighter real quick. And what I'm going to do is I'm going to highlight red something. So this was what was our base area, right? So depending on what the shape of it is, we would find the base area. Now, if you were looking at the cone, what would be the base area of a cone? Well, if you look at the bottom of a cone, it's a circle, right? So the area of a circle is pi r squared. So right here, we're off to a good start. It's the exact same thing. So we're dealing with our base area. Then we have this portion right here. We're looking for 1/2 slant length times perimeter. So what that is actually doing, that's telling us that we're trying to find the area of each triangle as we went around. So to do that, we're going to do the slant length times the perimeter, or the dimension around that. Now, what is the perimeter of a circle, though? We don't deal with perimeter, we call it circumference, and that's 2 pi r. So if I was to relabel this portion of it, because this should match up to the other one, right? So if I was to rewrite this as we would here for a pyramid, it'd be 1/2 the perimeter of a circle, which is 2 pi r, right? So that's the circumference times the length. There's our length, there's our length. They match up. So what's 1/2 of 2? It's 1, so that's pi r L. So in essence, these are still the same things. You're just dealing with circles. You'll have to use circumference instead of perimeter, pi r, 2 pi r, but they cancel out with a 1/2, and then the area of the base. So again, you don't have to memorize it as just this. That's just showing you that it is the exact same formula. It's just that we're dealing with different base dimensions. That's why they look a little different. Alright, so let's work through a few problems. We're going to deal with just the cones for right now. So if I'm given a cone and I want to know what's the surface area of that cone, I need to know the radius, which I happen to know is here. They gave it to us from center to edge. That's a radius. And then this 3, because it's on the edge of this, we would assume that this is the slant length. Now if they had marked the 3 here where it was perpendicular to the base, then that would be our height. So notice that this height is different than the slant length. The slant length goes down the ridge or the slope of the cone, and the height is perpendicular to the base. It's straight up and down from the base. And you can tell it's straight up and down when you see that little right angle mark. That means it's perpendicular. Alright, so I'm going to move this over just a little bit so we're just focused on this formula. And again, this is just from the IXL problem that I have up. Important thing when you're doing surface area and volumes is to really identify your dimensions, like label them or write them down so it's easier for you just to fill in problems. So I'm going to write down my R first, and this is going to come back into play as well with helping you identify variables in algebra, because a lot of my algebra students they have to do that as well for a system of equations when we're dealing with word problems, and then also with direct and inverse variation. So it's really important to get in the habit of labeling variables. So your radius was 2 meters, and our slant length is 3 meters. And knowing that we have our stuff labeled now, so let's just go ahead and plug it into the equation. What I am going to do is I'm going to go ahead and replace pi with 3.14. So r is going to be 2. We're going to square that. .14 is our pi. R is going to be 2, and L is going to be 3. You could put this all into Desmos all in one go, but if you don't have Desmos available right now and you're just using your calculator on your phone, let's just treat it like that for right now, and then I'll show you how to put it into Desmos after we're done. So we're going to put in the first part here. So 3.14 times 2 squared, 12.56. So I'm going to write that underneath. I'm going to press enter. Oops, I guess since I have to type it back in. Alright, let's try it again. Alright, and then I'm going to multiply the next one, so 3.14 times 2 times 3, 18.84. I'm going to press enter again. Or at this point, you could do one other thing. You could also just press plus, if I was select it back. Plus, and then you could use the last answer that was up here, so plus answer, that was our 12.56, or plug it in and you get 31.4 is our answer. They were meters, and with area, it's always square units, so 31.4 meters squared. Now, if you wanted to, again, you could do a couple of different things with Desmos. So I'm going to show that now. Oops, don't want to do that. Second, I made a mistake. So. Let's try that again. With Desmos, I'm going to, so just I'm going to clear this all over. So you can do one of two things. If you set up your labels ahead of time, r equals 2, slant length equals 3, just like how we did on our form over here, right? You can then press enter, and then you can go ahead and write this exact equation into Desmos. My only suggestion though is to not use the pi button that's down here. It would be in your best interest to just do 3.14, and then you can do r squared. Notice 12.56. 12.56 is what we got here, so far it's taking it okay. Then you can write plus 3.14 or L, because we already have all those all labeled, 31.4, and it's the exact same thing. So notice that's another way that you can do this. Either one of those are fine in setting it up into Desmos, so you can do it bit by bit on your own. You could label them and put them in. And then the last thing you can do, which I kind of hesitate on showing, but you can do only because it is very common for entry mistakes to occur. So what we can do is to put them all the numbers in. So you can do 3.14. Now my suggestion is here is to use the parentheses 2 and then end the parentheses, because if it's a -2, that's going to be different. So you're going to then square it. So always use parentheses around the value of your variable. Plus 3.14 times 2 times 3. You still get the same answer. Now what you could do as well is you could replace this with just like that instead of the parentheses. The only takeaway is you won't use it for surface area so much. It will be in other problems later on, especially like with evaluating expressions. It's important to still put the parentheses around that, because otherwise if it's a negative number, it's going to be calculated incorrectly. So that is another way you can do that. All right, and notice it's the same answer, so I'm going to clear. I'm going to put that answer in. Let's see, it says to the nearest 100th, so we actually have it to the nearest 10th, because there wasn't another number after that. 100th is our second decimal place, so we're good. So I'm going to just write 31.4 square meters. Brilliant. Awesome. So let's try the next one, where they want us to the nearest 100th again. So I'm going to scroll down. Actually, no. Let's just erase it. It'll just be easier. Alright, again, it's best to label your dimensions. So we need to know our radius and our slant length. Now, radius. This one, they did not give us the radius. They gave us, not the radius, but they gave us the diameter. It went completely through the center. So we know that is going to be our diameter, and our radius is always half that, because it's from center to edge, so it's half this distance, so our radius is going to be 2. And let's include the units, so 2 feet. And then our slant length is going to be 4 feet. Alright, so we know our dimensions. Let's go ahead and plug it in. So 3.14 for pi. Radius is 2. Square that. Then we got 3.14 for pi. Radius was 2. And our slant length is 4. So let's plug it in. It's 3.14 times 2 squared gives us 12.56. So then we can do 3.14 times 2 times 4. That's 25.12. So again, you can just type those two values in. 12.56 plus 25.12. We get 37.68. And remember, it's feet squared because we're dealing with surface area. Now they wanted us to round to the nearest hundredth, which we already are. The hundredth is the second decimal place. So we can go ahead and just plug that into IXL. We're good to go. Alright, let's do one more and then we're going to jump up a level. So I'm going to erase that real quick. So here we're looking at our radius right now. They already gave it to us from center to edge. That's 4 centimeters. And our slant length is 13. So let's go ahead and label those on our paper. So radius is 4 centimeters. And our slant length is 13 centimeters. Alright, now that we got everything labeled, we can go ahead and fill it into our equation. So 3 and 4 times radius squared, so 4 squared plus 3.14 times our radius of 4 times our slant length of 13. Alright, let's enter that into our calculator. Figure this all out. 3.14 times 4 squared, 50.24. Plus 163.28. So we're going to add these two together. So that's 213.52. And that's going to be centimeters squared. So that will be your final answer, because again, it's already to the nearest hundredth, so we can go ahead and just type that in. Got it right. So I'm going to jump up a level. This time we're dealing with decimals. And I'm going to clear out my work. So our radius in this case was already given. It was 5.1 feet. Length is 14.7. So then we got our stuff labeled, so let's go ahead and plug it in. .14 times 5.1 times 14.7. Alright, so let's go ahead and plug that into our calculator. So it is in your best interest for problems like this is to write out the whole thing. So I plug that in, and again, it would be in your best interest to write all of it down because you want to round at the end, not beforehand. Whoops, here I am writing the same thing again. $235. 4058. So now we're just going to add those together. So what I'm going to do is just to shorten on the time, so I'm not holding you up with having to type it in. You could just press the answer button. It takes in the last answer. Add the 81.6714, which is just up here. And we're just going to round to the nearest hundredth, so this is 0.07. 0.077, so looking at the third decimal place to round it to the second, we're going to then round up because the second 7 is greater than 5. So that causes us to round up to the nearest next hundredth, so that's going to be 0.08. So we'll plug that into Excel real quick, we'll be good to go. And we did well. I am going to try real quick to see if I can pull up let me see if I can pull up a pyramid question so we could work at least a few on those. So what I am going to do is I'm going to try to move this out of the way. I'm going to erase this cone stuff over here. We're just going to work underneath here for a second. Oh, actually, better yet, wrong button. Okay, let's just try. Let's see if I get good luck or bad luck. Alright, good. Okay. So this is with dealing with a rectangular pyramid and actuality, can't get that word today. So we're not actually dealing with a rectangular pyramid because if you notice this is 9 and this is 9, so it's not a rectangular, it's a square-based pyramid. So let's label our dimensions. First one on our formula is the slant length, and that's going to be 10. Remember, that's the one that's that goes along the diagonal, the edge. So that's going to be 10 millimeters. Then we're going to deal with P. P stands for perimeter of the edge of the base, so we want the perimeter of the base. Okay, and our base shape, so P stands for perimeter. The base. So our base shape is a square. So you can do this one of two ways. You can add up all the sides, which may be easier for you to remember rather than having to deal with the perimeter formulas that are already on your formula sheet. So if you were to do that, you want to add up each side, and the most common mistake is not add up all the sides. So we have 9 plus 9 plus 9 plus 9. How did I get that? So it's a square. So going from this side, we would add 9, 9. This dimension is 9 as well, and this dimension is 9. That means then we would add those all up, where you could just do, instead of 9 plus 9 plus 9 plus 9. You can do 9 times 4, which is the perimeter equation for a square. And 9 times 4, or 9 added to itself 4 times, is 36 millimeters. And then the last dimension, or last variable we need to define, is our area of our base. And to do the area of the base, you would, we have a square, so again, you could just, since it's a square rectangle, you could also think of it as just length times width, but our lengths are the same, so it's just 9 squared for a square. So 9, you either do just 9 times 9, or you can think of it as 9 squared, because it is a square. So 9 squared is just 81 millimeters squared. All right, so we have all of our variables defined. So now we can just plug it in. Slant length is 10. Perimeter of the base was 36. And our base area was 81. Multiply 1/2 times 10 times 36. We can use Desmos. So 1 divided by 2. 1/2 times 10 times 36. You get 180. And you want to do 180 plus 81. Go to the next line. Whoops. So you can either type in 180, or you can press the answer button. Plus 81, and you get 261 for your answer. And then the units would be millimeters squared. And it's already to the nearest hundredth. Let me double check with 10 if they needed. Yeah, they just, okay, so let's put that in. They already gave us the square millimeters. I press submit, and we got the correct answer. What I'm gonna do is I'm gonna just change these dimensions. Let's see if I can get another one real quick. So I'd like to do one more. Come on now. Alright, well, we're gonna have to use our imagination then to get these dimensions. I'm gonna make these numbers up, so hopefully I want to do at least one more problem with y'all. So using our imagination of a pyramid, let's see if I can draw this all right. So we're just going to look at one side. I'm going to try my best to have the try one more time. Alright, then there would be an like the invisible dimensions here. I'm going to make this a rectangle. So I'm going to say that this base length is 4 by 5, and then I'm going to say that the slant length, this will be our slant length. Well, it should be right here, but I can't draw it on there nicely because I didn't draw it big enough, but I'm going to say our slant length is 7. Alright, so I already gave you the slant length of 7. We'll make it feet. Now I want the perimeter, so if I was to add all these up, you could do 4 plus 5 plus, what is this back here? Well, if this is 4 and this is 4, I guess it's a rectangle, they're the same length, so 4 plus 4 plus 5 plus 5. So you could do it that way, 4 plus 5 plus 4 plus 5, or you can do 4 plus 5 times 2, or 4 times 2, or sorry, 2 times 4 plus 2 times 5. Either of those work, but you still will get the same answer of 18 feet. So that's with adding up all the sides around the perimeter, and now we want our base area, and it's a rectangle. It's be 4 length times width, which is going to be 5, and 4 times 5 is 20 feet squared. And now we just plug it in. So 1/2, slant length is 7, the perimeter was 18, and the base area will be 20. So we could just go to Desmos. So 1/2, 7 times 18, and you could also have, you don't have to because it will automatically think that's multiplication in between the 1/2 and the 7, but you could add that there too, just for your sake, and then that's going to be 63. It's 20. So add these together, just to make quick maths. 60 plus 20 is 80. 3 plus 0 is 3, so that's 83 feet squared. So that would be our answer if we did it that way, and just to show you that that is the case, I'm just going to make this quick. I'm just going to add the 20 at the end, and we get 83. So hopefully that made sense. If you have more questions, you can email me. Didn't get many watching today, but I will do another live stream tomorrow. And I'll do live streams of the new stuff coming up next week as well. Just take your time. Don't like stress yourself out. Just feel free to email me if you have any questions, and I'll get back to you as soon as I can. I miss y'all a lot, and I hope you're doing well. And I will see y'all tomorrow.